Welcome to CK Physics. The objective of this experiment is to be able to demonstrate how ammeters are connected in series to be able to measure the amount of current in a circuit. The equipment that I have, number one, I have a dry cell and I have a dry cell holder. I have a lamp with me here, you may call it a bulb, and I have two ammeters and connecting wires. And the first task is for me to place my cell in the cell holder. If you check the cell, my right hand end is the positive terminal and the right side of the holder is a longer line showing you it is a positive terminal. So I'll place my cell to go in line with that electric circuit symbol. So my cell here will be my source of electricity, and to be able to supply electricity to my lamp, I will connect the positive terminal onto one end of the lamp, and then the other end of the lamp will be connected back to the source. I will connect it using another wire in this format, and when the circuit is complete, I'm able to have my light coming on, indicating that the circuit is complete. So the question we might want to ask ourselves here is, how can we tell the amount of current flowing through the circuit? We can do that by connecting an ammeter in series with the appliance. And to be able to construct such a circuit, I will have my ammeter in line here, so that from the source of electricity from the positive terminal there, I will connect it to the red end of the ammeter, because the red end is the positive terminal. After that, from that red end, I will connect the negative terminal onto one end or one terminal of the bulb, and then from that one terminal of the bulb, I'll connect it back to the source. And if I complete that circuit, you'll get to notice my bulb lights with the brightness it was lighting earlier, and there is a deflection on my ammeter. If you check the deflection there, it is slightly over 0.2 amps. Now, the fact that the brightness is exactly the same tells you that the ammeter has not taken in any current. That is the reason we connect ammeters in series, because they have negligible resistance. Now, to be able to demonstrate that current is not used up in the circuit, I'll just open up the circuit at that point and connect another ammeter in series with the initial ammeter and with the bulb, and I'll have it connected from that point back to the source. Here we are. And when I complete my circuit back to the source, there we go. Both ammeters will deflect and the bulb is lighting with the same brightness it was lighting earlier. The initial ammeter is reading 0.2, just over 0.2 amps. If you check the second ammeter, it is reading equally just over 0.2 amps. That tells you that current has not been used up, because the same current from the source is the same one that comes back at the end of the circuit. Recognize, ammeters are always connected in series with the appliances. The appliance in this case is the bulb, and those are the ammeters. The reason they are connected in series is because they have negligible resistance. That means they have such little resistance that we can think of them as having no opposition at all to the flow of current. Thank you.